Hello learners, on behalf of Indira Gandhi National Open University, I am Shubhashish Maji, Professor in Mechanical Engineering of School of Engineering and Technology, welcoming you for this video lecture session. Today's topic is hydroelectricity and its environmental issues. This topic is from the course Energy Resources and Conversion Processes. So, dear learners, let us begin our discussion. After listening to this video lecture, you will be able to understand hydroelectric plant. You will be able to know hydroelectric plant in India. You will be able to describe stored energy and available energy. You will be able to explain the power, heat and flow rate related to the hydroelectric plants. You will be able to know the environmental issues due to the hydroelectric plants, and also finally we shall discuss some case studies on hydroelectric plants with regard to the environmental issues. Hydropower is one of the most important renewable sources of energy. It is clean, free from pollution and generally has a good environmental effect. In India, currently we are having 197 hydropower plants above 25 megawatt plus capacity and 9 pump storage stations as of 31st March 2020. The total capacity is 47,057 megawatt for hydroelectric plants and ranks 5th in the world for potential hydropower capacity. Dear learners, we all know that energy is the most important input for economic growth and human development. There is a strong two-way relationship between energy consumptions and economic growth. But presently in India, the total capacity for power generation is 371 gigawatt. Out of this, we generate electricity through thermal power plant, where we use coal as the fuel for generating electricity. But my dear friend, you all know that coal, fossil fuel, natural gas, these are all conventional sources of fuel or energy, and these sources are limited, or there is a finite reserve of coal. Now we have to use these resources, that is, we call it the non-renewable sources. We must use judiciously so that there should be a sustainable development, and we must keep these resources for our future generations. Now, when you think of the renewable sources of energies, we can generate electricity through solar energy, wind energy, hydroelectricity, on biomass. Then there are other different sources, we call it renewable sources, like tidal energy, wave energy, geothermal energy. So today we will discuss about the most important renewable energy sources, that is hydroelectricity, hydroelectric plants. India is having several hydroelectric plants, but we can name few before the discussions of hydroelectricity. One is Tehri Dam, that is on Bhagirathi at Uttarakhand. The capacity of this hydro plant is 2400 megawatt. Koyna hydro plant, that is on Koyna river, that is at Maharashtra, capacity is 1960 megawatt. Sri Shailam Dam, that is on Krishna river, located at Andhra Pradesh, capacity is 1670 megawatt. So there are several hydroelectric plants already is there in India, and the capacities are different for different hydroelectric plants. In hydroelectric plant, energy of water is utilized to move the turbine, which in turn run the electric generators. Water heat can be naturally available or it can be created. In hilly region, water heat can be naturally available in the hilltop natural lakes. In plain land, it can be created by constructing dams across suitable rivers. In comparing to a thermal power plant, hydroelectric power plants are more eco-friendly as they are free from fuel combustion. The conversion of energy carried by water into electrical energy is carried out by the turbo generator, a rotating turbine driven by the water and connected by a common shaft to the rotor of a generator. Stored energy and available energy. Water held at a height represents stored energy, and we all know that if is the mass of water placed at a height h, then potential energy is mgh, and the stored energy is 1000 VGH, because we know very well that mass is equal to density into volume. The density of water is 1000 kg per meter cube, and if we put the value of density, then we can get the stored energy is equal to 1000 VGH. So here mass is equal to density into volume. So density is equal to 1000. So stored energy we are getting as 1000 volume. So we are getting the stored energy is equal to 1000 VGH, where V is the volume, G is the acceleration due to gravity, and H is the height at which the water is placed. Now you come across the word that is pumped storage. This process is very simple. Electric energy is converted in gravitational potential energy when the water is pumped from a lower reservoir to an upper one, and the process is reversed when it is released to run back down. A suitably designed generator can be run backwards as an electric motor. The machine which converts mechanical energy into electrical energy can perform the reverse process. A suitably designed turbine can also run in either direction, either extracting energy from water as a turbine or delivering energy to the water as a pump. So we call it, these are pump storage. Now let us have some understanding of power, heat and flow rate. The power available at any time is probably the most important factor for any hydroelectric plant. This depends on volumetric flow rate. So P is equal to 1000 into QGH. So Q is the volumetric flow rate, and G is the acceleration due to gravity, and H is the height available for that water. So if we consider the efficiency, then obviously power is equal to 1000 into eta. Eta is the efficiency of turbine multiplied by QGH. So if you want to convert in kilowatt, we have to divide by 1000. So finally we are getting power in kilowatt is equal to 10 eta QH. So 10 we are getting because we have taken the value of G roughly as 10. Now let us see how we can calculate the available power. So if for a case 1, if Q is given as 800 liters per minute and height available is 25 meters and eta is given as 85%, that efficiency of the turbine is 85%, and then we can calculate with the formula for the power that comes out for this case is equal to 3.33 kilowatt. But for the second case, if Q is taken as 3000 meter cube per second and H is taken as 100 meter, and if you take the efficiency of the turbine is 83%, then the power available is 2.5 gigawatt, such a big turbine. How do you know about the types of hydroelectric plant? These are known by the effective head of water, by the capacity, the rated power output, by the turbine used, by the location and type of the dam, reservoir, etc. Now, selection of site for a hydroelectric plant. Factors to be considered while selecting the site of an hydroelectric plant. We have to see for availability of water, water storage, water head, availability of the site, distance from the load center, and of course the type of land site. Environment consideration for hydroelectric power plant. In operation, it doesn't release CO2, that is carbon dioxide, or oxides of sulfur and nitrogen. It does not produce particulates or chemical compounds such as dioxin that are directly harmful to the human health. It emits no radioactivity. Dams may collapse, but they will not cause major fire. So these are the advantages for hydroelectric plant. However, during the 20th century, the construction of large dams has led to the displacement of many millions of people from their homes, and dam failures have killed many thousands. We will consider this and other deleterious effects under three headings: hydrological effects, water flows, groundwater, water supply, irrigation, etc., other physical effects of large hydro plants, and of course we will discuss about the social effects. Hydroelectric effects. Diverting a river into canal or a mountain stream into a pipe may not greatly change the total flow, but it can have a marked effect on the environment. Other physical effects like dam failure, plant failure, silt, fish and methane gas, these are also very important factors while considering any hydroelectric plant. Social effect. When a dam is built in a place, there may be several problems arise for the local people who were residing in that areas. They may have to leave the place and had to settle down in a new area. This resettlement may not suit for majority of the affected persons and creates a conflicting situation. So, when there is any dam constructed in a hilly region, so it takes it creates a lot of problem, because the persons, those who are residing in that particular area, they may have to leave that area. They have to settle in a different place where the place may not be liked by all the persons, or the persons may not like to leave their original place where they were living for several generations. Example of social effect: the Aswan Dam at Egypt and Kariba Dam at border between Zambia and Zimbabwe involved the relocation of some 80,000 and 60,000 people respectively, whilst the Rising water behind the three Gorges Dam at China submerged about 100 towns and displaced over a million people. Environmental aspects. There are some advantages like produces no atmospheric pollution, neither consumes nor pollutes the water it uses for electricity generation, produce no waste, avoid depleting non-renewable fuel sources, because if we use hydroelectric plant for our power generation, so definitely we can reduce the power generations for thermal power plant where coal, oil or natural gas are used. So if we use more power generations through hydroelectric plant, then we can avoid depleting non-renewable fuel sources. Very few greenhouse gas emissions relative to other large-scale energy options, and of course the hydroelectric plant is very much useful because if we use this, then very few greenhouse gas emissions relative to other scale energy options. So it can create new freshwater ecosystems with increased productivity. Environmental aspects. There are disadvantages. So those disadvantages are inundation of terrestrial habitat, modification of hydrological regime, modification of aquatic habitats. Water quality needs to be monitored or managed. Sediment composition and transport may need to be monitored and managed. Greenhouse gas emission can arise under certain conditions in tropical reservoirs, and barriers for fish migrants and fish entrainment. This is one of the major issues for hydroelectric plant. Now, if there is stagnant water in a reservoir behind the dam, if there is stagnant water in the reservoir which is there behind the dam, then some plants may be rotten at the bottom of the reservoir, and that can emit methane gas, and that methane gas is one of the main greenhouse gas, and if it emits to the atmosphere, then definitely it will lead to more global warming. And barriers of fish migrants and fish entrant, these are also creates a major problem because of the construction of the dam. If there is a flow of river is less, then the fish while breeding they go against the flow of river, so it is not possible for them because of the dam construction. So this also creates a major problem. Social aspects. So leaves water available for other uses. Advantage often provides flood protection, may enhance navigation condition, often enhances recreational facilities, because you might have seen that in some countries that the dam is one of the prominent and most important sightseeing for the travelers or those who are. Dear learners, let us discuss about the advantages with regard to the social aspects. So points are: leaves water available for other uses, often provides flood protection, may enhance navigation conditions, often enhances recreational facilities. You might have seen that these dams are the attractions for the tourist, and if you go to the country like Egypt, there you will find that there is a tourist place at Aswan Dam, and that place is visited. This place is most attraction place for the tourists. It provides opportunities for construction and operations with high percentage of local manpower, because if there is a dam construction, then a lot of job opportunities will be there for the local people, and definitely the local people will be benefited and their economic condition will be improved, and also it improves the living conditions and sustains livelihood, freshwater, food supply. Social aspects. There are disadvantages. It may involve resettlement, that is a major issue, and it may restrict navigation, and local land use problems will be modified, and it also creates waterborne disease vectors, and effects on impacted people's livelihood need to be addressed with particular attention to vulnerable social groups, and it also affects on cultural heritage for the shifting of the place which are very important, say for example temples and other historical buildings or constructions or heritage buildings are there, they have to shift from that place to other place while constructing a big dam. Economic aspects. Advantages: provides low operating and maintenance cost. It provides long lifespan, because for a hydraulic plant life is for 50 to 100 years. It takes few minutes to run the plant. It provides reliable service, can navigate and foster region development. It also creates employment opportunities, and the most important thing is that no fuel charges is there for the hydroelectric power plant. Disadvantages with respect to the economic aspects. Initial cost of the plant is very high. It takes long term for erection of hydroelectric plant. In some large cases, the storage capacity of reservoir may decrease due to sedimentation. It requires long-term planning. It requires multidisciplinary involvement, because for a hydroelectric plant, civil engineers are involved, electrical engineers are also involved at the time of power, at the place where power is generated. Civil engineers are for constructing buildings and other civil structures, and also it often requires foreign contractors and funding. Some case studies on environmental issues. So here we will discuss some very interesting case studies. One is Galloway hydro plant. Second one is Gapsikawo Nagimaru's hydro plant. Third one is Gorges hydro plant, that is the biggest hydro plant in the world, located at China. And we will also discuss about Ethiopian Renaissance Dam, that is also known as Millennium Plant Dam, and also we will discuss hydroelectric projects at Brazil, at Ethiopian. Hello learners, let us discuss some very interesting case studies. One is Galloway hydro plant. This hydro plant was constructed on River Dees at Scotland, and the first proposal came in the year 1890. The scheme feasible after establishment of national grid in 1920. Just see, it took 30 years to pass the scheme, and initially commissioned this dam in 1935. So you see, 45 years it took for constructing this Galloway hydro plant. And there are a lot of issues when the dam was constructed. The main problem was salmon fishing, because all the 6 dams constructed for this Galloway hydro plant at different locations, and all the dams were on salmon fishing rivers. When the dam was constructed, the flow was less in the river, and the salmon fish, that is a very popular fish in that area, and during spawning or breeding, they were not able to swim in the opposite directions of the flow of river. So after that, they made some series of pools. Those are known as fish ladders. So step by step the pools were there, and the water was flowing near the dam to the river through that fish ladders, and the they found that the fishes, they were having no difficulty in swimming in the opposite directions of the flow of river through the fish ladders. So next case studies is Gapsikovo Nagimaru's hydro plant. Proposal of constructing a dam on river Danube between Slovak and Hungarian for 880 megawatt capacity. First proposal started in 1977. There were a lot of opposition on environmental issues. Started in 1980. Construction on Hungarian side stopped in 1989 because there were two dams. One is at Slovakia and another one is at Hungary. So because of the lot of oppositions for constructing these dams, mainly on environmental issues, and Hungarians stopped their construction for their own dam. In 1992, Hungarian government cancelled 1977 agreement, and in 1993, Hungarian and Slovak government took the dispute to International Court of Justice at Hague, and in September 1997, the court ruled that both the countries had acted illegally. They have not considered the environmental issues when they were planning to construct these dams, and the dispute went on for several decades. This is one very interesting case studies for the Three Gorges hydro plant. Originally proposed over the river Yangtze at China in 1919 during Sun Yat-sen period, and culminated its approval in 1992. Just see that several years, this around 73 years it took for starting this large dam. Construction began in 1994 and completed for this dam construction in 2003. Largest hydro plant, installed capacity 22.5 gigawatt, and there were 32 turbines for this Three Gorges plant having capacity each 700 megawatt, and there were two turbines having capacity 50 megawatt, and these two turbines having capacity 50 megawatt, these were mainly to supply electricity for the dam equipment only. The dam flooded archaeological and cultural sites and displaced some 1.3 billion people, and there were several important places were submerged because of the construction of this dam, and there were a lot of objections or resistance against this constructions of this dam, and the World Bank, who were initially funding, they stopped funding this dam, but the Chinese people, they managed through some other financial organizations for funding this plant, and this is the largest hydroelectric plant in the world. And you will be surprised to know that because of a lot of mass accumulated for the reservoirs, and they have changed the rotational time of the Earth around its axis, and NASA has calculated the rotational period for the Earth against its own axis, and they have found that few microsecond enhanced time is there for the rotational period for the Earth around its own axis only, due to the massive dam constructed in China for that particular place. Now, this is one very interesting case studies, that is the Grand Ethiopian Renaissance Dam. Construction at Ethiopia on River Nile started since April 2011. Actually, Ethiopia neighboring country is Sudan, but there were an agreement in between three countries like Ethiopia, Sudan and Egypt. And this dam has been almost constructed and opening date announced, that is 2020 and 2022. This hydroelectric plant is 7th largest hydroelectric plant in the world. Installed capacity is 6.35 gigawatt. There are 14 turbines, 400 megawatt, and 2 turbines, 375 megawatt. The reservoir could take 5 and 15 years to fill with water. Egypt, which fear disastrous consequences if its vital share of the river's water is reduced, has protested against Ethiopia's decision. Now, the 90% of the water for the use of Ethiopians comes from the river Nile, and the construction of this big dam at Ethiopia will create a lot of problem, and the Egypt government, they said that they will obstruct for starting this big dam, and they requested US government to intervene in this matter and settle some and come out with some feasible solution. But still Ethiopian government, they are not agreeing, and Sudan is also joining hands with Ethiopia so that the big construction of dam should not start because of the water issue, because British people have given the rights to the two countries like Ethiopia and Sudan to have the rights over using the water in river Nile. So they have the right whether Ethiopia will use the water of river Nile or not, and the dispute is still going on, and even a lot of money has already been invested for this dam, but still the dam is not going to start because of several environmental issues. The large hydro plant in Brazil, the construction at Itaipu on Paraná River between Brazil and Paraguay started in 1975. Last two of its 2,700 megawatt dam on line in 2006. Installed capacity is 14 gigawatt. Turbines, there are 20 turbines having 700 megawatt. Paraguay's requirement is 50 Hz alternating current, but Brazil's requirement is 60 Hz AC current. Now Paraguay, which uses 50 Hz electricity, uses only a fraction of its share. The rest is sold to Brazil, where it is rectified, transmitted as DC and then reconverted as 60 Hz. So this big dam is in collaborations with two countries like Brazil and Paraguay, but Paraguay's requirement is very less. The majority of the power is they are selling to Brazil, but Brazil uses 60 Hz, but the Paraguay's requirement is for 50 Hz electric power. So they are first rectified it for DC and transmitted with a high voltage DC to Brazil, and again reconverted as 60 Hz for using at Brazil. Now let us very quickly summarize what we have discussed for the hydroelectric plant. We have discussed about the hydroelectric plant. We have discussed hydroelectric plants which are located in India. We have discussed stored energy and available energy. We have discussed the power, heat and flow rate related to the hydroelectric plant. We have discussed about the environmental issues for hydroelectric plant, and we have also discussed some very interesting case studies on hydroelectric plant. Thank you very much.